I'd like to now introduce Alistair Fussell. Alistair is the manager of Steel Construction New Zealand, SCNZ, an organisation dedicated to advancing the interest of New Zealand's steel structural industry. Alistair is a chartered professional structural engineer with specialist knowledge in the design of steel structures and is a member of the Steel Structures Standards Committee.
Thank you. Yes, well, I'm probably going to be a little lightweight after Charles's very technical session there. I'm going to really talk about a few more commercial matters, which probably might be of more interest to quantity surveyors and building owners and the like. Really, I'm, as I mentioned, going to be talking about some of the commercial aspects of steel construction. And really, I hope that the key takeaway you come from this session really is that it makes good commercial sense to consider steel structural solutions for your building projects. Well, this is really just to give you a little bit of an outline of where we're going to go in the next 20 minutes. I firstly want to quickly overview a model comparison study that we had. We commissioned some design and construction professionals to undertake on our behalf. They produced a model building. In this model building, they did some cost studies, some construction studies. We really wanted to come up with some hard data so that we could be able to make some comparisons between the financial merits of various types of systems. And I'll be looking to just thread some of those figures through my presentation. And really, in terms of the commercial case for steel construction, I'll really be looking at it as under 5 key commercial considerations, and we'll just knock them off one at a time. So that's where we're heading. We approached Auckland-based architects, Architectus, and we said to them, look, our brief is we want you to develop a low-rise building, probably about 4 stories. We would like it to be something that would meet the current commercial market for a mixed-use building. Primarily it would be office space, and perhaps on the lower floor you might look at putting retail in it. So this building here is it's about 70 metres long by 18 metres wide, so it's about 1,300 square metres. And this building here would fit with the Christchurch City Council's vision and the Central City Plan for a low-rise rebuild of Christchurch. We then approached engineers Aurecon, and we had Sean Gledhill was the project leader on this to look at putting some very structural solutions into this building. We had steel solutions, timber solutions and concrete solutions put into this building. And they're supported on screw piles. They're probably something that you'll see a bit more of in Christchurch. They suited to using in low-rise, lightweight construction. Well, really, the first commercial consideration for in terms of steel construction, or is really that it's a cost-effective material. We engaged a local quantity surveyor, Peter Eggleton from Capital Projects, to just run his eye, put some numbers over the 3 different options that were developed and to come up with some cost estimates for these various options. And really, if you take nothing else away from that plot up there, I really want you to take away the idea that there's really not much difference in terms of the structural systems that you choose to use for these sorts of buildings. Those of you who are wondering whether you can get a building for $2, it's actually supposed to be $2 million as the cost. Now, just to understand as well what that cost represents, it is just the cost of the foundations and the superstructure, all of the stuff such as fit out, the cladding, the roofing. We figured it was the same for all of them, so it hasn't been considered. So that's really just your fit out costs, just your structural costs. So you can see in there, timber came in at the lowest at $1.95 million, about $10,000 difference to the steel solution, and then slightly more to the concrete. But there was only really 2% difference across it. So we're saying you can get the seismic resilient benefits of structural steel solutions without having to pay a premium to have them. The second commercial consideration around steel construction is that it's a very fast form of construction. As the Minister has alluded to, things have changed from probably 30 years ago, where you would regularly see welders and sparks from people welding on sites. We certainly don't do that anymore. It's much more efficient if we do all the complex manufacturing operations in the controlled environment of a workshop. Much easier for welders to do it, much easier for engineers and inspectors to come in and see what's going on. And so it's primarily what you see with steel construction. You can see examples over here. Essentially, you get simple stick fabricated components come to site, goes together like a big Meccano set. You'll see there's cleats, bolts in there. And generally, you'll find that you require very small rigging crews. You probably can't see, but this was a 20-plus story building in Auckland. It was the new B&Z building on Queen Street. There's actually 2 guys rigging it, plus a guy on the crane, and that would have been the size of the crew they would have used for that building. It doesn't take many people to actually rig these buildings. As a rule of thumb, and we've got this from one of the local builders, and we found this with our own studies, rule of thumb, structural steel buildings are generally 10 to 15% faster if you look at the overall construction program compared to a concrete alternative. So it's a very fast form of construction. Now, we've actually had help from Mainzeal, who helped us to look at the construction aspects of this project, and they have a very smart building information modelling manager in their Auckland office. They're getting into BIM technology, Mainzeal, and he's actually put together a very clever animated sequence showing how these buildings go together. So rather than putting these old bland bar charts that you often see for construction programs, he's produced an animated sequence, and I'm hopeful that it'll actually work. And it really just shows the difference in the speed of construction. Oh, there it goes, it's starting to work now. So this building's being built. You've got your foundations, your ground beams are going in. You've now got the various floor systems are going in. And we're going to find the first milestone that we strike in this project. This is the completion of the structural steel solution. Now, just in terms of background to this animation sequence, when they did the construction programming for this job, they assumed that it was a design-build contract. They programmed it, and they assumed that all the design documentation, the consenting, all those things would take the same length of time. And so you'd see that they all started essentially with the piles going in at the same time. So the assumption was that you get to site at the same time, you'd start work on the piles at the same time. So that's your at the first stage. So the timber structure is pretty well advanced. Still haven't put the concrete floor in. Still got to put the roof on. Sorry? Oh. For the concrete one, you've still got the floor to put on, so now we'll let this thing go. So about 25 days later, we get the timber structures all ready. It's ready to be made watertight. For the concrete structure, you've still got to put the roof structure on it. We'll let it run its course, and I'm very impressed that it's actually worked. And there you have it, hey presto. So if only it was this easy to rebuild Christchurch. Well, really, what I want to do now is just to focus on the end of the project and really make the point that the speed advantage you saw in the actual construction of the superstructure actually translates into the overall construction program. And so you can see that steel's speed advantage when you look at the sort of Manhattan Sky Towers there. As you can see over there, 304 days was the duration for the contract for the steel building, 319 for the timber. So we're essentially saying if it's 15 working days, it's about 3 weeks. And then 343 days, which is for the concrete option. So that's about 39 days or just under 8 weeks difference. And that rule of thumb of about 10 to 15% in this particular project, the steel structure was about 12%. So it fits within that range. Well, someone asked the question, so what? If you build your building faster, is there any real value in it? Certainly if you listen to the news coming out of Christchurch, there are people in the local business community who think that it would be good if you could get some of your key building stock back in the city, particularly around hotels at the moment. You're significantly down on hotel accommodation at the moment. You're certainly in need of stadiums, events, conference centres and the like. So certainly from the perspective of the overall economic benefits to the Canterbury region, there will certainly be benefits in seeing some of those built quicker. You probably heard recently there's a whole lot of conjecture really about how quickly the office CBD rebuild is going to happen, and there's thinking that maybe it won't happen for a while. Interestingly though, it will be good for the Canterbury region if even for the ones that do get started with, there's some research has come out of the UK where they've done studies on efficient building design, and they've actually found that the design of your office has a big impact on the productivity of your workers. And I imagine that in Christchurch at the moment, some of you are probably working in less than ideal offices. I've been to visit engineers in town, and they were sort of in was like a two-story flat. They were all in, jammed into this little office. And it's interesting, they've done statistics or surveys and research, and they reckon that, good office design, you can improve productivity by 3 to 20%. So I imagine if you get a few of these people out of some of these old buildings and some new ones, it'll probably help as well. Well, so that's really on the regional level, but taking it down to probably a level that's of more interest to some of you who sit here who are property developers, who are people who own buildings, you're probably more interested in the next slide, which really perhaps zeroes in rather than at a regional level, thinking, well, what's the benefit of building your buildings a bit quicker if you get down to the level of a developer or a building owner. Now, you probably are struggling to see some of these figures over here, so I'll make sure that you can get them. You will see them in your, we've got a document which is in some of the material that was left that you've had in your seat when you arrived, so you can really have a closer look at the figures. But probably the third commercial consideration for steel construction is the fact that you get earlier rental income streams, and you also get reduced financing costs. Now, we've done a simple bit of mathematics. We took some of the commercial property data that was in the Colliers International did a report for the Christchurch City Council, and it was in the back of the appendices of the Central City Plan, so there were some nice figures there on Christchurch rentals. So we were able to do some quick mathematics on our building just to calculate what was the value in terms of the weekly rental on our building, which it has about 1,170 square metres per floor of net leasable area. There are 4 floors, so we've assumed that we've got 3 floors of offices and 1 floor of retail. Now, for this particular building, the rental income is about $43,000 a week that you're looking at. And if you would look at the financing costs, and that assumes that the developer is using bridging finance to finance the whole project, which and using the methodology in that Colliers International report in terms of interest rates and the methodology, it's worth about $13,500 a week in interest to the developer. So you don't have to be an Einstein to put some quick numbers on these differences there. If you get in 3 weeks earlier, in terms of that's the comparison between the steel and the timber option, you'll see in there, that's about $130,000 extra income in your pocket if you're the building owner. And if you're the developer, well, you've saved about $40,000 in interest costs. Well, it gets even better if you look at the comparison with the concrete option. You're dealing with nearly 8 weeks difference. Now you're talking about rental income of about $335,000 extra dollars, and your bridging finance, well, you're looking at just over $100,000. So the difference there in terms of the value of construction time can be quite significant. Well, the fourth financial consideration that I want to look at in terms of steel construction is that when you use resilient materials like structural steel, there is the potential for better insurance outcomes. I'm sure most of you are, if you read the newspaper, or you don't have to look too hard to find articles written about the soaring cost of insurance in New Zealand. And what's become apparent from that is that the insurance industry are already starting to look at the expected seismic performance of buildings and use that to inform make their commercial decisions in terms of, well, I guess all we've experienced is just a huge increase in insurance premiums. The interesting thing is that essentially what they've done, and I guess it's probably a crude approach, or the best approach they can use at the moment, is that what's happening is buildings that are built before 1979, which I guess is considered to be a time when the seismic codes, seismic design provisions are starting to get perhaps more modern. They pretty much said that's the cutoff. Anything before that, your buildings are going to attract a much higher increase in your insurance premiums, and if your building was built before 1936, you're probably going to actually find it quite difficult to even insure the building. One thing that's happened in the wake of all the economic damage caused by the Christchurch earthquakes and sequence of events has been that there's been a call to set up a seismic rating system, and the intention of the system would be that it would communicate to non-engineers, non-technical people the seismic risk associated with different types of construction. And we've actually got, there's actually a New Zealand system which is being proposed at the moment, and we have actually got one of the proponents of that system who's going to be sitting on our panel discussion tonight. Now that system is really based on a North American model, and essentially that North American rating system considers 3 key performance indicators for the seismic performance of a building. It looks at, and it rates them from 1 to 5. It looks at life safety. We're obviously well aware of that, and we've seen that in Christchurch, that generally our standards have dealt well with that. But the other two issues of repair costs, we obviously haven't done so well. They rate that, looks at, would you expect the building to suffer more than 5%, 10% of its value in damage? And the last one is time to regain function again of the building. So is it a matter of days, weeks, months, or years maybe, in terms of when you go to look at your building? So really, for people who use structural steel, it's been a proven seismically resilient system. And if you were to go and do as Sean's been promoting, looking at using low damage seismic solutions for buildings, and they're generally not that great a premium. If we get this QuakeStar system introduced into New Zealand, there could well be a commercial driver in the market that sees designers who are prepared just to pay a little bit more to get a building that performs above the minimum building code performance requirements, that there could be commercial drivers that see them rewarded in terms of it's highly likely the insurance companies will recognise this and want to give lower premiums. And you'll probably find that there's a lot of safety conscious tenants around who are probably starting to look at their buildings a bit closer now before they enter into them. And the final commercial case for structural steel construction is that steel construction is actually a very good system for future-proofing your investment. Nothing erodes the commercial value and rental returns from a building to find that your building is obsolete when it comes to the property market requirements, or to find that your building, with the changes in the seismic the building code seismic requirements, you suddenly find that you have a building that has a lot of deficiencies, and unless your building can be cost effectively upgraded to meet the market, that you really stand to lose a lot of money. And the good story for structural steel is that it's actually, and Charles has already talked about, long span construction. You can actually cost effectively produce clear spans of up to 25 metres. Gives you very, very open plan floors. It means that when you have future tenants who might want to come in and be able to maximise the flexibility for your office, it's a good option. The other thing with structural steel is that you can actually upgrade or change your buildings easier than other materials. For example, there was a building at Waikato Hospital. Now, this probably wouldn't go down as a necessarily good way to procure buildings or how to manage your procurement of a building, but there was actually a Waikato Hospital. There was an emergency department building well through the construction, and then there was a decision was made that they'd add a couple of extra stories to this building, so the project sort of ground to a halt as everybody figured out what that meant for the structure, there was a lot of steelwork had gone up. Some of it could be taken back to the workshop to be strengthened. Other bits of it just had to stay on site, and they repaired it or strengthened it. The job carried on, and it's now finished, and it's got 2 extra floors on it. So you can actually modify these buildings. You can upgrade them. In terms of seismic upgrades with steel buildings, you can get braces into these buildings. You can strengthen the connection. So they're certainly a good way of future-proofing your investment. So that's really I guess the 5 key commercial considerations for structural steel construction.